Okay, we're going to look at piecewise functions. So, a little vocabulary review. A function is a relation where each input has only one, I should say exactly one, output. A domain, that's a set of inputs accepted by the function. Range would be a set of outputs, that results from the inputs. All right, so a piecewise function is a function with more than one formula / equation. So the formula tells us what to do with the input to get the output, or you can think of that as like the answer. All right, so a set of more than one formula is used to define over different pieces of the domain. So we're used to functions looking like this. Now we're just saying there could be more than one piece. Remember, these graphs would look something like 2x plus 7 might look like that, one line. We've already seen some of these graphs, but this graph could not be written from one equation. You got to think of this as three separate pieces put together to make a new function. So we've been looking at their graphs, but now, like, what are the equations going to look like? Well, they're going to look things like this, where the equation has two different pieces. All right, or here, you could even have three different pieces. Remember that this is the function name, and this is our input. All right, we read that as f of x as a reminder. That's how we say that. It's not f times x. Evaluating piecewise functions. So evaluating just means if I gave you an x value, could you plug it into the function and get the y value? So it's just like before, if I told you like f of x is 7x plus 3, you would just substitute in -1 for x. Well, that's what we're doing here, except now you have two choices, right? So I'm going to highlight these in color. You have a choice of this guy you could plug it into, or that guy you can plug it into. How do you know which one to plug it into? Well, let's try to stay color-coded. So for this one, this part right here tells you use this piece of the function, right, for x values less than 0. I'll put the 0 over there. All right, so when I say use this piece, we're talking about the highlighted purple piece right here. Okay, so this just is like your domain is saying, if x is less than 0, we're plugging it into this piece. If x is bigger than 0, let's go green here. If x is bigger than 0, I'm going to choose a darker green just so it will show up better. If x is bigger than 0, we use this piece. So we'll use the bottom piece for x values greater than 0. And that only leaves one number left. What if our x value is 0? Do you use the bottom piece or the top piece? And in this case, you will use the bottom piece because there's an or equals to sign. So use this green piece or bottom piece for x values greater than 0 or x values equal to 0. So let's try this. So f of 1, that means we're going to plug 1 in for x into the function f. So here's my function f, and if x equals -1, that's what we're plugging in. -1 is less than 0, so we're going to use the first piece. Because this x value, -1, that I'm plugging in for x, fits this inequality. -1 is less than 0, so that means we refer to the purple piece. So I plug -1 in for x in the purple piece. So I get -7 plus 3. -7 plus 3 is -4. All right, so that's the answer for that. Now let's go to f of 0. So f of 0, that means that our x value is equal to 0. Right? This is the x value we're plugging in. And it seems that 0 is equal to 0. So that fits our bottom green domain. So that means we're going to use the bottom piece. So 0 is greater than or equal to 0, right? So that fits our bottom piece. So that means we're going to use the second piece or the bottom piece to plug in 0. So it's going to be 7 times 0 plus 6. 7 times 0 is 0. 0 plus 6 is 6. Okay, let's look at f of 2. So f of 2, I want to decide, I'm plugging in the x value 2. So I have to decide, where does 2 fit? Does 2 fit in the purple domain or in the green domain? Well, 2 is bigger than 0. So that means 2 fits in the bottom domain, which means I use the bottom function, the bottom piece. So I'm going to use the second or bottom piece to plug in 2. So f of 2 would be equal to the bottom piece, which is 7x plus 6. And I'm substituting in 2 for x. So I have 14 plus 6, which is 20. All right, so that's how you evaluate a piecewise function. First, you determine which piece are you using based on these domain restrictions. These are the domains. That tells you, based on the x you're plugging in, it tells you which domain the x fits in, and that determines which piece of the function you use to evaluate it. So this one says a cell phone company uses the function below to determine the cost in dollars for gigabytes of data. All right, so find the cost of using 1.5 gigabytes of data. So again, maybe if we color code this, I'll make the top piece, let's say the same colors. Pink up top. Whoops, I'm going to erase that. Or purple. I don't know if that's pink or purple. I think that's purple. And then the bottom piece is this equation. The domains over here, they tell us which piece to use. So find the cost of using 1.5 gigabytes of data. So that means that G is going to be equal to 1.5. So 1.5, which one of these domains does it fit? Is 1.5 in between 0 and 3, or is 1.5 bigger than or equal to 3? Well, 1.5 is in between 0 and 3, so we use the top piece. So the function up top is 30, and there is no G to plug 1.5 into, so the answer is just 30. So no matter how many gigabytes you use, the cost is 30, and I guess that's in dollars, right? So let's say it cost $30. That one's kind of weird because there's no G to plug into. If I look over here at 30, there's no G to plug it into. So no matter what G is, if it's between 0 and 3, it's just $30. And that makes sense. A cell phone company for the first 3 gigabytes might just say it's a flat rate of $30, then start charging you an overage for when you go over 3 gigabytes. And then the more you go over, the more expensive it gets. So that's why you have like an equation here. The G, as G gets bigger, this cost gets bigger. Okay, find the cost of using 4 gigabytes of data. All right, so if we look at G equals 4, because it says 4 gigabytes of data, where does G equal 4 fit into? Which domain? Right, whoops, let's do it this way. 4. Is 4 the G that's between 0 and 3, or is 4 bigger than or equal to 3? Well, it's bigger than or equal to 3, so now I use the bottom piece. And so that would be 10 times the 4 gigabytes plus 15. This will be the cost. So 10 times 4 is 40. 40 plus 15 is $55. Okay? That's how you use a piecewise function. Sometimes they can be represented by a graph. We've already sort of done piecewise graphs. They're a lot easier to do because you're just looking at the graph. So given the function to the right, find the following. F of 2. So I go to 2 on the x-axis. Right here, I go down until I hit the curve, and I look over and say, what is that y value? It's -1. Okay, let's do another one. F of -3. So I go to -3 on the x-axis, and I look up, and I see when I hit the curve. I don't hit it here. An open circle means you don't hit the curve, so I keep going through until I hit the closed circle. That is where I hit the curve. It looks like to me it's going to be 2.5. Then f of -1. So I go to -1 on the x-axis, and I look to where I hit the curve. I look up, and it's an open circle, so I don't hit the curve. I look down, it's an open circle, I don't hit the curve. I don't hit the curve anywhere, so if there is no y value, we say undefined. We don't know what it is. It's not defined. The y value is not defined. All right? Now let's look at f of -4, composition of functions. So we start with the inside first. We start by finding f of -4. So f of or I'll do it on the side over here. Eraser. F of -4 equals. So I go to -4 on the graph. I look up, I hit the curve here, and I look over and say, what is that y value? Oh, it's 2. So f of -4 is 2. So now I'm going to do f of 2, because -4 equaled 2. So I plug in 2 I replace 2 for all of f of -4. That was the output for an input of -4. So now I got to find f of 2. So I go to 2 on the x-axis. I look down. I hit the graph. I look over, and that looks like it's a y value of -1. All right. For number 4, we'll probably talk about this one in class. That is it for our video today. Awkward ending engage.